Good morning, Year 12. We're going to be looking at variation this week. The lesson today is investigating variation, so you're going to do some field work, and I'd like you to learn how to collect data and interpret the results at an A-level standard. As your starter for today, I'd like to see if you can recall from the meiosis topic what are the causes of variation in an animal species. I'm going to show you some images, but I'd like to see how many you can remember without the images. So pause the video and then I'll reveal some images, pause it again and see if you can figure out what the 4 causes of variation are. So here's 4 images. Look at those, see if they jog any memories for you. Have a look, see what you can think from the causes of variation. So the answers are then, we've got the crossing over, so when the chromatids cross over and the genetic material from one chromatid transfers to the other. You've got the independent assortment during anaphase 1, which is when the chromosomes line up. They line up in different orders each time. You've got the fact that it's random fertilization. Any sperm could coincide with any egg, so therefore you've got variation there. And then you've also got the idea of random mating. That male beetle there could mate with either 1, 2 or 3 beetle, depends which one it comes across first. So important to remember that variation isn't always caused by genetics. Variation can also be influenced by the environment. As you can see here, these 2 lawns, one has been affected by drought and is a completely different colour, and the one on the left there has been in an environment which most likely had plenty of water on it. So variation, that doesn't have to just apply to animals as well, so it's important for you to remember that when you're talking at A-level standard, we wouldn't just be talking about animals, you'd be talking about plants, you might be asked about fungi. There is variation across all organisms that can also be influenced by the environment as well as their genetics. However, most variation that you will see is mainly a combination of both environmental and genetic variation. So I've got these 2 trays of plants here. The genetics will determine the shape of the leaves, they'll determine what size the leaves grow, they might determine the height that a plant can grow to. You'll see you've got different sized trees and that's determined by the genetics. However, the environment determines how and what size those actual leaves grow to. So even though they're the same species of plant, the bottom one there with the round leaves, the ones that have been in a nutrient-rich environment, they've been able to grow to their maximum size. So your task today involves getting out of your house, which is why I asked you at the end of last term if you could let me know if you didn't have access to the following garden. And only 2 people got back to me, so I'm assuming that everybody else has got access to a garden in their houses. So what you're going to investigate is you're going to investigate the variation in different plants across different areas of Macclesfield, and we're going to find out if the results of this experiment show that the location does affect either the width of grass blades, the diameter of a clover leaf, the petal length of daffodils, or the diameter of dandelion flowers. So just in case you're not sure, I thought I'd put 4 pictures up there because sometimes people get confused between dandelions and daffodils, but hopefully that's a reminder for you. So we're going to look at how we make sure that our data is not biased. So what you'd normally do is you'd map out your area where you're going to look for your organisms. It's all too easy to, if you're being asked to look for dandelions, you may decide to just go where you can see the largest dandelion, and that would be a biased sample because you have purposely gone to that area to get that exact sample. So when we do unbiased data collection, you might use a grid method like this. the grid method works if you've got a tool that can do random sampling. If you've not got a tool that could do that, let's say you're out in the field and you didn't have internet access or you didn't have electronics with you, you could always roll 2 dice and see which directions the 2 numbers come up. So instead of having A, B, C, D, E down the side, you could have another set of numbers and you could roll 2 dice. It's an alternative method. But you've got access to phones and you can easily find a coordinates generator. They're really simple to find, just Google it, you'll find one really easy. So once you've put your maximum coordinates into your coordinate generator, a coordinate will be given to you, you pop that in and it will reveal the square. So I would go to D6 and then I can sample the organisms in that area. There's 4 organisms in that area, as you can see there. So I would maybe go with another random method there, choosing 1, 2, 3, 4 and see which one comes up. So how might that look in your garden? So we're going to look here. This is my garden. I hope there's a shot of it. So in my garden, I've got some daffodils here, and they are sporadic. So I wouldn't use the grid method in this particular instance. That's because I could end up doing the coordinates loads of times and I wouldn't actually get to where the daffodils are. So another method that you can use is that you can, so let me just rub those off, is that you can just highlight exactly where all of your samples are and give each of those a number, which you can then put into a random number generator. From there, all you need to do is go to the number that is generated and then choose your plant when you get there. Again, you can number the plants like I suggested on the previous slide. So let's say like here at number 5, there is at least 4 or 5 daffodils there. So you can go from there to figure out which one you want to sample. That makes sure it's completely random. There's no bias. You've not chosen the area. It's just selected it because of your random generator. So obviously when we're doing the grass, you wouldn't do that with the grass because this area here we have got a lawned area. So I'll show you on the next slide what you would do. So as you can see, the grid method will work on the lawned area. Obviously, anything with number 1 isn't really going to work, but it might do for yours. Probably should have done that a bit lower. So do your coordinates generator, get your generation, see what comes up, and then you're going to go to the square that maybe comes up on your coordinates. So for mine, it was C4, and then I'd go to that square and I'd just randomly pick and I'd look to see if there was any clover, and I might take a sample of the clover, or I might just randomly choose a clump of grass and measure one of the blades of grass on it for the width. It's all about making sure that you've not selected the best area. Like here is not a good area for my grass, whereas over here it's really thick and lush. So I might be, if I hadn't got this grid, I might be tempted to go over to this area here to get a sample, because that area there would have thicker grass and it would be more appealing for me to go look at that area. But we've got to make sure that we're not biased with our samples. So once you've got your grid method, obviously you're going to need to record your data. Now it's really important that you get this data ready for us for tomorrow's lesson. We need to use it as part of the next lesson, and everybody else in your class will as well. So I'd like you to make sure you record your data like this, and then I'd like you to follow the link and I'd like you to record it in the Excel spreadsheet that I've provided. It is really important that you do that because, like I say, we need it for the next lesson so that we can calculate standard deviation for it. So I know some of you weren't completing your work on time before the end of half term. It's really important that we get that done this time for me, please. Okay, and when you're done with those tables and you've done your results, make sure you've calculated the mean for each of your samples. And I will speak to you tomorrow to see what we're going to do with those results. Any questions, just message me, I'll show you my homework.